Hello everyone, welcome to this channel. So in this lecture, we will talk about two important terminology in probability theory. Sometimes we also call this as a language of probability. So these are sample space and events. So first, let's talk about what is a sample space. In our last lecture, we already talked about what is one experiment in probabilities. So experiment is anything can produce some data. And here, the sample space is all the possible outcomes generated by this experiment. So for this one, sometimes we denote this by capital S, and sometimes we divide it by a Greek letter, which is omega. So this depends on the textbook you choose. So here, a sample space, in fact, is a set. So later we will talk about some rules of the set. But before that, I want to give you some examples about this. And the outcome here in the sample space, they generally denote by some numbers or some letters, something. But if this is some numbers, then we have two types of the sample space. So they are discrete and continuous. So what is discrete? So this is something you can list the outcomes. So it could be some numbers, like the natural numbers. So you can list them by 1, 2, 3, or 10, 11, 20. But compared with discrete, the other one is continuous. So continuous is something, of course, you cannot list. So this will means the outcome is between some interval. So let me give you some examples about some sample space. You can do this as an exercise with me. The first example is if we roll a regular 6-sided die. So they are in the 6 sides, of course, they are number 1, 2, 3, 4, and 5, 6. So in this case, what is our possible outcome we can get? So it's maybe 1, maybe 2, maybe any one between among the 6 numbers. So in this one, that means for our answer, our sample space. So here I denote this by capital S. So then I say this S is equal. Here I use this symbol to generally use for the discrete sample space. So this is, I can list all the outcome we have is 1, 2, 3, 4, 5, and 6. So this is what our first example, and we can also know this one is a discrete sample space. Okay, is this clear for everyone? And then let us give another example. The second one is if we flip a coin. So what we will get? We will get two possible outcomes. So one is we can get a head face, and the other one is we get the tail. So that means here we can have two possible outcomes. So that means for this sample space is still we can list the outcome. So this is also a discrete sample space, and we can get we can denote this sample space by S equals the tail, and we can get a head. So this is the answer for this question, and we know this is also a discrete sample space. Okay, so now we have two examples of discrete sample space, and let me give our third example. So this third example is about the finance example. So this is the price of 1 share of Apple stock. So what we will know is we can now list the answer, right? Because the answer actually can be any number for example, any non-negative numbers. So here, if we want to write this answer, so this answer will be S is equal, if we assume X to show the price of this stock, so we can write this X given X is greater or equal to 0. So that means here we write this as the answer to our sample space. So the price of Apple stock can be any non-negative value. So this is consistent with the rule of the stock market. However, actually, if you play with the Apple stock, maybe you will know it's not 0 like for the past maybe 10 years or past 2 years. The Apple stocks is maybe higher than $50 or higher than $80. So then actually instead of use number 0 here, we can rewrite this number 0 to some other number, something more fit or reasonable number. It can be any non-negative numbers. Okay, and then for this one, this example of course is not a discrete example. So this is a continuous sample space. Okay, so this first 3 example is kind of a short answer. So let me give a more complicated example. So this example is about signal sending. So assume in this experiment we send 3 signals in sequence, and then we will record whether these 3 signals will arrive or not. So it's denoted by capital letter A or N. So for this sample space, it's still about all the outcomes we can have. For example, if we receive the first one, not receive the second one, and receive the last one, so it will be A, N, A. Okay, and also in these 3 signals, both of them, any one of them can be arrive or not. So in this one, we will have several outcomes, and of course we can list them. However, it will be a little difficult to write them very clearly. So let me give you a method to write it. So for the first signal, of course, we will have 2 results. The first one is A, arrive, and the second one is capital N. So that means it's not arrive. So this is the outcomes we can have for the first signal. However, for the second signal, based on the answer we have for the first one, we will have actually for each, when the first one arrives, then the second one can still have arrive or not. So that means after the arrive the first signal, we still have 2 possible outcomes. And then same for the case when the first signal not arrive. We also have arrive or not arrive for the second signal. And then the situation is similar for the third one. No matter what happened for the first 2 signals, for the third signal, it still have arrive or not. So now if we look at this tree graph, we can know, in fact, at the end, we will have actually we will have 8 different cases. So then for our sample space, we need to write all of them. So how to do this? So we can, for example, let me circle this one. So the first possible outcome is we choose all as the left branch. So we will have our sample space as equal, the first one is A. So all of the signal is arrive. And then there also, if we choose a different branch, like we choose A and choose the right branch as the third signal, then we will have an answer as A, N. And we will do this for all of these tree pictures. Like the next one is ANA. So ANA. And the next is ANN. And then we move to the right branch of this tree picture. So it will have 4 additional answers. So this is an answer to this question. So that means for this sample space, we will have 8 possible outcomes inside this sample space. So here for this one, in fact, the difficult part is how we can write all of the outcomes and don't miss any of them. So you need to be careful about this. So here, let me give a last example about this sample space. So this question is about draw a card from a deck. So if when we first draw one card, we get a collapse or a heart, so we will stop immediately. So that means in total, we only draw one card. However, if the first one we draw is not, then we will continue draw another card and then stop. So that means in total, we will draw 2 cards. So in this case, when we talk about the first draw, of course, we will have possible 4 outcomes. So it's about the spade, the collapse, the heart, and the diamond. And then what's the difference? Now, if we have the club and the heart, we will stop immediately. However, in the other 2 situations, we will continue draw the second draw. So for this second draw, then what we can have, then of course there is still 4 situations. So we will still have this 4 different types of the second draw. And this is same for if our first get a diamond, we still continue to our second draw. So in this one, now we can also have a tree table. So here, if we want to choose from this tree table, of course, this time I will still start with the left branch. So that means for our sample space S, the first one we can have is get a SS. And then we can move this to the one right branch. So SC, SH, and also SD. So this is the first 4 possible outcomes from this experiment. And then what's the next one? So now the next one, this is a little different because now what we have, we can only have 1 draw. So that means for the next outcome, the possible outcome in this experiment is only a C. So we only get a collapse when we have first draw and then stop. And the next is only get a heart. And then after this 2, this is still go back to 2 draw. So it's DS, DC, DH, and double D. Okay, so this is in total we can have 10 possible outcomes for this experiment. And similar to the previous example, we use the tree graph to help us find all of the outcomes. And then we can list these results. So this is also about one example of discrete sample space. So this is about the sample space. And then in this lecture, we will talk 2 terminology, right? One is the sample space, one is events. So now let us move to the events. First, let me give the definition of events. So events is a subset of a sample space. So here, how we can decide a subset of the sample space. So this depends on what event we interested. So for example, here, if we use the previous 5 examples to help us here. So the first one is still about the rolling die. So in this one, the sample space is S equal 1, 2, 3, 4, 5. And here, if the event we interested is about one result. So in this one, then what we can have this event is only one outcome, which is what we interested is get 6 when roll this 6-side die. So here, this result is a subset of the previous sample space. And this one, we denote this by capital E. So we say E is equal only one outcome, 6 here. And for the donation of this event, sometimes we use E, and when it's several events, we maybe use E sub 1, E sub 2, E sub 10. But they also have some people use like capital A, capital B. This depends on your hobbies, but generally we use the capital letter to denote this. And then let me give you one more example. So this example is about the flip a coin. So here, what event we interested? If we only interested an event of the get a tail, then for this event, we will just have E is equal tail. So this is our answer. And then for the stock price, then maybe we only interested in stock price between some specific branch. For example, 200 and 300. Then for this one, we will only interest in X between the 200 and 300. So we can denote this by an interval, looks like this. Okay, so this is one example of the continuous, the event of a continuous sample space. And also we have another example. The fourth example is about the signal. 3 signal, we record they are arrive or not. So now the event I'm interested is here. I'm only interested if we receive the second, exactly the second signal. So in this one, then that means, in other words, the first and the third one are not arrive. So that means we will have NaN. So this is an event here for this example. And then the last one is about draw a card. So now this event is if you only interest in draw clubs at some point. So we don't care about we draw a club as first draw or second draw. So here that means what we will have is we will have 3 possible results. So 2 of them is we get the club as second draw, and 1 is we immediately have it as a first draw. So this is an example of the sample space and event, and hopefully you now have a clear idea of what is a sample space and what is event. So in the next lecture, I will talk about some rule of the set, because we already say sample space is a set, and then the event is a subset of this sample space. So in other words, it's also a set. So then before we play with them, we need to know the rule of sets. So see you in the next lecture.